In the previous video, we showed just how easy it was to create an OData REST-based service using SAP HANA Extended Application Services. We're able to define a service definition document by referencing a single table or view, and we got a lot of built-in functionality, the ability to sort and filter and otherwise narrow down our result set, and all that was built in. We didn't have to program it. But what happens if you want more programmatic control over a service? Maybe you want a custom body format that isn't supported by OData. The OData format gives us Atom and JSON. Maybe you want something different. Maybe you want plain text, maybe you want XML, maybe you want text tab delimited, or maybe you want more processing control over how the selection is done. Maybe you want to do some calculations, something more complex than what you could represent in a single view. Maybe you want to call a stored procedure and have multiple result sets come back out of it, or something like that. Well, fortunately, there's also a full programmatic environment inside of SAP HANA Extended Application Services. We have a JavaScript virtual machine inside the system as well. We actually use the Mozilla SpiderMonkey virtual machine, and therefore you can take the JavaScript skills that you likely already have from doing client-side development in the web browser and reuse that knowledge on the server side as well. We use server-side JavaScript. And let's go ahead and create a simple example of some server-side JavaScript, just something that will take two input parameters from the client side and multiply them together and then return the result. Not necessarily the most powerful example of what you can do, but it's a very simplified example on purpose. It allows us to focus on the process and the fact that we have complete programmatic access to the HTTP request and response object, and also complete control over the body and the body format. So we'll start by creating a new object inside of our project, and we'll just say an XS JavaScript source file. And this will automatically create an object that has an extension of XSJS. That's how we know that this is going to be server-side JavaScript. There we are. Part of having the XS project type also gives us access to the server-side JavaScript APIs. So there are a series of built-in APIs on the server side that give us access both to the HTTP object, but then there are also specialized APIs for interacting with the database, making external communication requests, and we have visibility to all these APIs and their parameters and everything here in the project, but also we have a specialized XSJS editor that will give us access to these APIs via code completion. For instance, if I begin typing here, RAN equals $ request. So I want to access the request object, and then I want the parameters for the request object, and then get. So we have code completion on the server-side APIs, and I'm also getting syntax checks as I type. We use JSLint to perform checks, and we've extended the checks that are available. So, for instance, you know, if I type something completely syntactically wrong here, you know, right away I get some warnings there. Equals 1. So we have lots of built-in functionality. Now let's focus more on the syntax of what I have possible with the server-side JavaScript. In this case, and this is usually where you might want to start, is some sort of command coming in to tell this service what it can do, what the user is requesting that it does. And already you're seeing we have complete control over the URL parameters they're used. You define their their meaning, which ones are available, which types. So this CMD, it isn't something specified by HANA Extended Application Services or XSJS. It's just something I, as the developer, am specifying. And then we might do a check on this. Switch on a command, and maybe I'd have multiple commands, but for this case, we'll keep things very simple. I'll put a case statement, but I'm looking for multiply, and when we do a multiply, I want to perform multiply, and that's a function that I'll add in just a few minutes. Break and default. This way, if any other command comes in that I wasn't expecting, then we can go ahead and handle that. So I can say response, set the status to at http dot okay, even though it isn't really okay. It's not a great situation, but I'll go ahead and I want the browser to respond with a message that's readable. And then I'll say set body, and then I can set whatever content I want into the body object. Command. Oops. Plus, and then we'll tell them whatever the command was. So already you can see we have lots of control here. We have access to the request object and its parameters. We're directly writing into the response object. I'm able to set the HTTP status for the response, and I can put content in whatever format I want back into the body of the response object. So this would just put a text description on the screen that said invalid command, and then whatever the command was that we typed in. Now let's put our function in that we called here that will actually do the multiplication. So let's say function perform multiply. There we are. So body, I'll declare a body object and set it initial. And then I want remember I said I'm going to receive two numbers in. So request dot parameters get, that'll give me access to one URL parameter with a number, and then I just want to declare a second one, number 2. So I can name these whatever I want. It's just the calling application has to obviously know what I name them. And then bar answer, somewhere to put my answer. So now we can do our arithmetic. Num1 times num2. Pretty straightforward. And then I can put the answer directly into the body. So answer to string. That will put the numeric answer, format it as a string and put it in the body. And then I can put that response dot set body, and I'll pass it that content. And that will put it back into the response object, which will cause it to display in the web browser. And then we probably want to response content type. So we'll set the HTTP content type. So this is text plain. Of course, we could maybe, there's lots of other things we could do here because we have complete control. Maybe I could do text tab delimited. Maybe I could do JSON. JSON is obviously very easy format to create. We just call it JSON stringify. It would be one of the built-in APIs of the JavaScript virtual machine. So that's obviously a very simple, but in this case it's just plain text. I don't need anything fancier than that. And then I can set the status to net HTTP. Okay. And you notice I had, as I typed, I had some warnings. I had some syntax checks. The warnings earlier would have been I declared a variable that hadn't been used yet, and then once I used it, it went away on that line until I had completed it. I had a syntax check, so you really see the you know, the syntax validity of your code as you're typing it. And I also have visibility to go directly to my function or variable that was defined in line. But basically, this should syntax check now. I didn't get any warnings, any errors, so I can go ahead and save this. And get. Oh, I did have a typo there. Now see, I misused one of the server-side APIs. There was no way that the JS lint could pick that up. I should have put a period in there. That's my mistake. So you're also seeing there are additional server-side checks once this is sent back to the server. So let's go ahead and save that again. Now commit. And actually, I misspoke just a moment ago when I said there were additional server-side checks. That actually wasn't a server-side check. There are additional JS lint checks upon save. So some checks are done as you're typing. Some checks can only be performed on a complete scan of the document once you save, but that was all client-side. It's only once we try to activate the object that we would get additional server-side checks. So that will happen now when I activate. And it's activated successfully. I can now test this in my web browser. So just like the OData service, we can test our service directly in the browser. So let me go to the path. Logic, and then demo main.xsjs. If I just run it directly, I'm going to get prompted for authentication, and I get invalid command undefined because I did not pass in a URL parameter named CMD. So if we go ahead and add something named CMD equals junk, now I get invalid command junk because it wasn't multiply. Therefore, we went down our default path and we're outputting invalid command and whatever the command was that we received. If I go ahead and say multiply, and I add two additional numeric URL parameters, one for num1, 5, and num2 equals 10, and then on the server side, we multiply 5 times 10 and get our results 50. Once again, not amazing functionality, to multiply two numbers. Certainly something we could do on the client side, but the simplicity of the example allows us to focus on the mechanics of how we handle URL parameters and interact with the request, the response object, and build the body. Now, this wasn't. This is just testing on the URL via the URL in the browser. That's not necessarily how end users at all would work with an XSJS service. More likely that the XSJS service would be embedded inside some form of HTML or mobile user interface and would be called to request data. So now let's look at an example of how we could use an XSJS service from inside an SAP UI5 project. All right, I've prepared an additional view in my SAP UI5 project in order to test the XSJS service. So if we look at the view, pretty straightforward. I'm creating a panel, and inside there I'm creating input fields for the value 1 and the value 2, and then a text view where we can display the results of our calculation. And I've attached event handlers to each of the two numeric input fields, and using a live change event handler. So as I type, it will automatically trigger the event, and the event is handled inside my controller. So this is the first time that we haven't just done our eventing in line, but we're actually delegating to our controller. Inside the controller, for the event handler, and each field basically has the same event handler, All that really changes is which parameters that we use. But we build the URL to our service, so pointing to our logic package and then demo main XSJS, and we fill the command multiply. That's the only thing we support right now, so we need to supply it dynamically. And then we take the parameters that are currently in the screen and we pass them in as the number 1 and number 2 URL parameters. And I'm doing escape on them to just make sure that they're safe encoded for passing via the URL. Then we're using the standard jQuery AJAX call, so we're making an asynchronous call back to the server to execute this XSJS service. jQuery is embedded within SAP UI5, and it actually forms the inner core of SAP UI5, so it's very easy to access and use it from within SAP UI5. And then the asynchronous event handler that gets triggered when we make the call to the server is on complete multiply. We registered both the success and an error event handler. And in here we get the results. So the body that comes back, this my text will be passed into the success function, and we're just testing to see if it's undefined. Otherwise, we clear it. If it is, then we use jQuery numeric formatter to properly format it according to the user's browser settings. So correct decimal and other numeric formats, and then we put it back into the screen. And if for some reason an error would occur, then we'll show a message box letting the user know that there was a service call error. So basic error handling. So let's see what this looks like at runtime. We'll go ahead and put in our path here. Oops. Let's another. Very similar to what we saw in the URL parameter, but a little nicer now. We've got some input fields and a place to show the results. So if I do 5, and already as I type, it's making a call each time I type. So it already did 5 times nothing, 0, but 1 and 10, and then we see the result is 50. And as I continue to type here, it continues to call back to the service, and you see that the numeric formatting is being applied on the client side. If I get it something completely invalid, I believe if I gave it a non-numeric value, so we're blowing up on the server side, but then we're handling that via the error of the AJAX call, and then showing an error dialog. I definitely should have put more details in there, the NA, but for testing purposes, at least I know that something went horribly wrong in that case.